Hello everyone, today I'm going to present my project about the Newton's law of motion done by Maher Ahmed Sawafi. Introduction. Newton's law of motion, relation between the forces acting on a body and the motion of the body. And Newton's law of motion are three laws that describe the relationship between the motion of an object and the forces acting on it. And in this presentation, I'm going to be explaining the types and examples of Newton's law of motion. In Newton's law of physics equation, law 1, every body continues in a state of rest of uniform rectilinear motion, and to change every object move in a straight line unless acted upon by a force. Law 2, the change of motion is proportional to the applied force and take place in the direction of the straight line along which that force acts. And Law 3, to every action there is always an equal and contrary reaction. Newton's first law. It is stated that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by a force. And this is a picture that explaining about the first law. Basketball, Newton's law of motion. Basketball, when a basketball player shoots a shot, the ball always follows an anchor path. The ball follows this path because it is motion in Newton's law substance. Law 1 examples. There are three examples. One of them about aircraft. The motion of an aircraft flying through the air can be described by Newton's if thrust and drag are equal and lift and weight are also equal, then the aircraft has constant speed and altitude. So lift and weight are equal and thrust and drag are equal, so all of them are going to be in a constant speed. Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. Acceleration of an object depends on two things, force and mass. And Newton's second law of motion is F equal ma, or force is equal to mass times acceleration. Law 2 example. The second law say that when an external force acts on a body, it produces an acceleration change in velocity of the body in direction of the force. The magnitude of the acceleration is directly proportional to the magnitude of the external force and inversely. And this is the picture that states the example of the acceleration and inversal force. Newton's third law. Whenever two objects interact, they exert equal and opposite forces on each other. This is often worded as every action has an equal and opposite reaction. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction of the force imposed on it. And this picture represent the elephant and the man, how there are force between them. Law 3 example. A person drive a cart 1, to the right while putting another cart 2, that has a massive refrigerator. On the total mass of cart 2, cart plus fridge is 3 times the total mass of cart 1, and it's massive, so and heavy too. Cart plus person, if the person is driving with enough force that the two carts accelerate to the right, what can be said for sure about the magnitude and the force of the cart, of the fridge, and the person? The correct answer is, first we have the force on cart 2 exerted by cart 1 could be larger or smaller depending on the size of the acceleration. 2. The force of cart 2 exerted by cart 1 is equal in a magnitude to the force on cart 1 exerted by cart 2. 3. The force of cart 2 exerted by cart 1 is larger in magnitude than the force on cart 1 exerted by cart 2? The answer is the second one. The force on cart 2 exerted by cart 1 is equal in magnitude to the force of cart 1 exerted by cart 2 is the correct answer. The references that I use in my presentation are the following: Kahan Academy, Britannica, Physics Classroom, Wikipedia, and more. And thank you for listening.